November 2013, Mathematics, Paper 1, 2 hours 30 minutes. Let's get right into it. First question is 1/5 plus 1/6. This is a fraction. So the easiest way is to find the lowest common multiple of the denominators. So we're going to look for the common multiple of 5 and 6, which is 30. Very simple stuff. So what we do now, we just multiply by 6 for the one with the denominator of 5 and multiply with 5 the one with the denominator of 6, because the common denominator of 5 and 6 is 30. Then the first one, 1/5 can be expressed as 6/30, and 1/6 can be expressed as 5/30. When the denominators are the same, we simply add the numerators, and then we get 11/30. The second one, 2/5 divided by 4 is the same as 2/5 divided by 4/1, because all numbers can be expressed as fractions with the denominator of 1. Then 2/5 divided by 4/1, it is easy also to divide by fractions because we just multiply by the reciprocal of the fraction. So 2/5 divided by 4/1 is the same as 2/5 times 1/4. We multiply the numerators, 2 times 1, we get 2. The denominators, 5 times 4 equals to 20. 2/20 can be reduced to its lowest terms by dividing with the common factor for the numerator and denominator, which is 2/2, and we get our final answer as 1/10. 1/4 times 2/3 in the order of, we use BEDMAS or BIDMAS or BEMDAS or BODMAS, whichever you want. So here it's going to be 3/4 minus 2. We want to do multiplication first, so we multiply the numerators, then multiply the denominators, which will give us 2/12. So it's 3/4 minus 2/12. Then we look for the lowest common multiple of 4 and 12, which is 12. So in order to make 3/4 a fraction of 12, we multiply numerator and denominator by 3/3. Then we get 9/12. So it's 9/12 minus 2/12. Again, if the denominator is the same, is simply subtracting the numerator, we get 7/12. All right, so take note to write the answers in the allocated space, in the space of the question paper. That is, never leave the answering space empty. Move on to the next question. Evaluate 0.3 cubed times 0.02 divided by 0.0008, and the answer should be in standard form. So let's expand this. 0.3 cubed is the same as 0.3 times 0.3 times 0.3 multiplied by 0.02, everything being divided by 0.0008. Now, when we are multiplying decimals like this, it's quite easy. We can take all the whole numbers, or take out the whole numbers, multiply them together, and then the total number of decimal places of all the numbers which we are multiplying together. For example, 0.3 here has got 1 decimal place, the other 0.3 another decimal place, 0.3 1 decimal place, 0.02 2 decimal places. So we need to add 1, 2, 3, 4, 5 decimal places to whatever we get by multiplying 3 times 3 times 3 times 2, and then divide by 0.0008. So 3 times 3, that's 9 times 3, 27 times 2, 54. And we need to add 5 decimal places divided by 0.0008. Again, if we have to divide a number by a decimal, we can convert the denominator by multiplying it with the number of decimal places to make it a whole number. And whatever we do to the denominator, we also do to the numerator. So here we need to add 5 decimal places, 1, 2, 3, 4, 5, which will give us 0.00054 divided by 0.0008. Now, what we have here is 0.00054 divided by 0.0008, which is the same as multiplying the denominator and the numerator by 1, 2, 3, 4 decimal places, 1, 2, 3, 4 decimal places. So it will be the same as 5.4 divided by 8. 5.4 divided by 8, now it's very simple. we can now work it out. It will be the same as 8 into 5, 0.8 into 54. That's because we get 48. So 6 times 8, that's 48. 54 minus that's 6. Remainder 6. Then we add another 0. 8 into 60, that's a 7. Because 8 times 7 is 56. Then it will be into 60, that's 7. Then remainder 4. The remainder 4, we're going to say 8 into 40, then it will be 5. So our final answer is 0.675. 0.675. All right. 0.675 is our final answer here. And then to convert it to standard form, its standard form should be expressed in the form a times 10 to the power n, where a is a number from 1 up to 9.9999, and n is any number. Now, the answer will be, we're going to move the comma one place to the right here. So it will be 6.75 times 10 to the power minus 1. Maybe a thing to note here is that if you move the decimal point one place to the right, then the power will be negative, and if you move the decimal point places to the left, then the power will be positive. That's a general tip to remember there. The temperature inside a freezer is minus 8 degrees. During a power cut, the temperature rose by 12 degrees Celsius. Find the temperature after the rise. That's very simple. What we'll do here is, this is a simple addition problem. So we're simply going to add minus 8 plus 12. If we're adding numbers on the number line, let's say it's a horizontal number line. If we add, then it means that the numbers are going to increase going to the right. If we subtract on a horizontal number line, the numbers decrease going to the left. So minus 8 plus 12 is the same as saying 12 minus 8, which is equals to 4 degrees Celsius. The next one, write down the next two terms in the following sequence. 1 over 2, 1 over 4, 1 over 8. You can see that each successive term from between each two terms here, it seems as if we are multiplying by a half. 1 over 2, 1 times 1 half gives us a half. 1 times over 2 times 1 over 2 gives us 1 over 4. 1 over 4 times 1 over 2 gives us 1 over 8. So the general term is a times half, where a is the first term or the term. So here we can see that the trend is multiplying by 1 over 2. So the next two terms would be 1 over 8 times 1 over 2. 1 over 8 times 1 over 2 giving us 1 over 16. Then that 1 over 16 times 1 over 2 again, it will give us 1 over 32. All right? 1 over 16 times 1 over 2 giving us 1 over 32. So the next two terms are 1 over 16 and 1 over 32. Remember to write your answers in the answer spaces given. All right, the first one was 4 degrees Celsius, and so we're going to write our answer here in the space provided. Then the second one was 1 over 16 and 1 over 32 for 2 marks. Next question, 3.35 minutes in minutes and seconds. This one is quite simple, but what you need to take note of is how to convert this fraction and make it into minutes and then seconds. So 3 is fine. Then 3 over 35, 0.35 is the same as 35 over 100. We need to reduce it to its lowest terms. 35 over 100 divided by 5 over 5 is the same as 7 over 20. So it is 3 and 7 over 20 minutes. So we now need to convert 7 over 20 of a minute to seconds. Remember, a minute is 60 seconds. So 7 over 20 multiplied by 60 is going to give us the number of seconds in 0.35 minutes. So we're going to write 3 minutes plus 7 over 20 multiplied by 60, because there are 60 seconds in 1 minute. So 7 over 20 multiplied by 60, 20 into 21, 20 into 60, 3 times 7, that's 21. So that's 3 minutes plus 21 seconds. 3 minutes, 21 seconds. So 3.35 minutes is the same as 3 minutes, 21 seconds. Write the answer in the allocated space. 3 minutes, 21 seconds. Second part, if 1 kilometer is 5 over 8 of a mile, convert 75 miles to kilometers. So now we are again having operations of changing between miles and kilometers. In Africa, we mainly use kilometers, whereas in some parts of the world, like in America and some parts of Europe, they use miles. So it is important to know how to interchange between miles. Sometimes you may buy a car which is showing miles per hour, so you need to know the speed at which you will be traveling. If your car has miles, let's say it's a European model or an American model. So now here, 8 over 5, 1 kilometer, since 1 kilometer is 5 over 8 miles, if we multiply both sides by 8 over 5 to remove the fraction part to get 1 mile, it means that 1 mile is equal to 8 over 5 kilometers. So 75 miles to convert to kilometers, we multiply by 8 over 5, which means we're going to divide by 5, then multiply by 8. 5 into 75 into 75, that's 15. 15 times 8, that's 120. So 75 miles is the same as 120 kilometers. Maybe a thing to note when you're working with miles and kilometers is that you should always that the number of kilometers, let's say for example, you have 20 miles and 20 kilometers. 20 miles is greater than 20 kilometers because the number of miles to convert to kilometers you need to multiply by 8 over 5, which is an improper fraction, which is a whole number, and a fraction which we call a mixed number. Next question, a shopper spent C over D dollars on one item and half of that amount on each of 3 other items. Find how much she spent altogether. So she spent C over D on one item and then 1 over 2 of C over D times 3. Okay, you have C over D plus 3 items plus 3 items each costing half of C over D. So this is the expression. Once you write this algebraic expression, then you know that you are good. You must always be able to formulate an expression given a number problem. So we get C over D plus 3 over 2 multiplied by C over D, which is same as 3C over 2D. So it will be C over D plus 3C over 2D. So now to work out this problem, we can find the common denominator, or we can just add the coefficients of the algebraic expressions. So here, since 3C over 2D can be expressed as 3 over 2 bracket C over D, what it means is we can just add the coefficients of the algebraic expressions, and then it will be C over D, which is the common. We can factorize common, which is C over D, then bracket 1 plus 3 over 2. Then what we do here is very simple. We just add the numbers in the brackets. All numbers can be expressed as whole number over whole number. So C over D plus 2 over 2 plus 3 over 2, which is the same as C over D multiplied by 2 over 2, C over D multiplied by 2 over 2 plus 3 over 2. So this gives us C over D multiplied by 5 over 2, leading us to 5C over 2D. Alright, so this will be our final answer, 5C over 2D dollars. So we write our final answer, 5C over 2D. We can also express it in the way 5 over 2 bracket C over D, but it's just easier to write like this, 5C over 2D. Next question is 3 to the power 3 to the power 4 divided by 27 to the power 3. To solve it, we can either express both of the numbers as powers of 3 cubed or powers of 27, because 3 cubed is equal to 27. So what we will do here, we are going to expand it. 3 cubed to the power 4 is equal to 3 cubed times 3 cubed times 3 cubed times 3 cubed and times 3 cubed. And 27 to the power 3 is equals to 3 cubed to the power 3, which is 3 cubed times 3 cubed times 3 cubed. Next, we are going to cancel out common factors between the denominator and the numerator. So 3 cubed and 3 cubed will cancel each other out. Another 3 cubed and another 3 cubed will cancel out each other. Another 3 cubed and another 3 cubed will cancel out each other, and will remain with 3 cubed. So our final answer, 3 cubed, can also be expressed as 27. That will be our final answer for this problem. A point to note is you can also express as powers of 27. The next we'll move on to B. 4x squared to the y to the power 6 to the power half. Remember the laws of indices, which state that any number x to the power half is equals to the square root of that number x. So this number 4x squared y to the power 6 to the power half can be expressed as 4 times x squared times y to the power 6 times y to the power 6, which can be expressed. Remember again the laws of square root, which is that if we are looking for the square root of a compound number, a times b times c, it is the same as the square root of all of those numbers multiplied together. So square root of a times b times c is equal to the same as square root of a times square root of b times square root of c. Therefore, square root of 4 times x squared times y to the power 6 is the same as square root of 4 times square root of x squared times square root of y to the power 6, which is equals to 2. Square root of 4 is 2. Square root of x squared is x. And square root of y to the power 6 is y to the power 3, which is equals to 2xy cubed, right? Then for c, x to the power 0 divided by x to the power minus 2 is very simple. It will be the same as x to the power 0. Any number x to the power 0 is equals to 1. So then any number x to the power minus a is the same as 1 over x to the power of the positive power, which is negative. So x to the power minus 2 is the same as 1 over x squared. So x to the power 0 divided by x to the power minus 2 is the same as 1 divided by 1 over x squared. Remember, to divide by fractions, we need to multiply by the reciprocal, which is x squared over 1. So 1 times x squared over 1 equals to x squared. So our answer is 3 to the power 3 for the first one, or 27. For the second one, it's 2xy cubed. And for the third one, it's x squared. Move on to the next one. Express 7 over 8 as a decimal fraction. Very simple again. 7 over 8 can be expressed as a fraction by doing short division. 8 into 7 is 0. Then we add another 0 there. We put a decimal point. 8 into 70, that's 8 times 8, which is 8. 8 times 8 is equal to 64, so it's 8. Remainder 4. Remainder 6. Then we put another 0. 8 into 60, that's a 7. Remainder 4. Then we put another 0. 8 into 40, that's 5. So by now you should have noticed that this paper has a lot of fractions in it. Decimals, mixed numbers, etc., etc. So in this paper you needed to have a thorough knowledge of fractions. A car loses 55% of its value after 4 years. If it cost 8,500 when new, find its value after the 4 years. So if it loses 55%, its value that it lost, we can use one of two methods. We can calculate 55% of 8,500 then subtract that amount from 8,500. So if we calculate 8,500 times 55% times 55 of 100, what we're going to get is 4,675. So that's the amount which was lost. Then we can subtract it from 8,500. So 8,500 minus 4,675 gives us, fast forward 40 by my calculations, 825. Our final answer will be 3825. However, there's a shorter method. Since the amount lost is 55%, the remaining is 45%. So you can simply calculate 45% of 8,500, which will still give you the same answer, 3825. Moving on to the next question. Now these are algebraic expressions and equations. First one, simplify 5m minus 2 bracket x minus 3m. So in order to do this, we must do the brackets first using our laws of operation for BEDMAS. So the 2 is going to multiply every term in the bracket. So 5m minus 2x, then minus times minus will give us a plus. So it will be plus 6m. So the next step is to bring like terms together. 5m plus 6m minus 2x. And it will be very simple from there onwards. It will be 5 plus 6, that's 11m minus 2x. That's the end. We've simplified it. We cannot simplify it any further. We stop here. 11m minus 2x in the answer space that we've been given. Next, solve the equation x plus 5 over 7 equals to 3 over 2. In this one, we first need to remove the fractions part. We can use several methods. Multiply by 7, then multiply by 2, or just multiply everything by 14, or cross-multiply the left side with the denominator of the right side, and multiply with the right side with the denominator of the left side. Whichever method you choose to use, make sure you follow through it and you get to the final answer, which is the same. So to solve this, we said we remove fractions first, then we solve the equation normally. All right? Whenever you get fractions, please remove them. It will make your calculations easier. X plus 5 over 7 equals to 3 over 2. We can multiply both sides by 7. Then we multiply by 2, since we have two denominators. So by 7, then by 2. Because it is an equation, whatever we do on the left side, we also do on the right-hand side. Now it will be, the 7 will out each other, and we'll remain with 2 multiplying x plus 5, which is equal to, the 2's will cancel out each other, 3 times 7, giving us 21. 3 times 7 is equals to 21. So 2 multiplying x plus 5 is equal to 3 multiplying 7. 2x plus 10, since 2 is going to multiply each term in the bracket, is equals to 21. Next step is to bring all like terms together. We can do this by subtracting 10 from both sides, which in effect will be making it cross the equal sign. So 2x plus 10 minus 10 is equals to 21 minus 10. Why? Because it's an equation. If we subtract a number on the left side of the equation of the equal sign, we also subtract on the right hand side of the equal sign. So 2x is equals to 11. We divide both sides by 2 so that we remain with x as the subject of the formula. 2 divided by 2 gives us 1. So 1 times x gives us just x. And 11 divided by 2 gives us 5.5 or 5.5. So x is equals to 5.5 or 5.5. 5.5 or 5.5. We've solved the equation. X is equals to 5.5. In this case, after you finish solving an equation, you can check whether the solved or the solution is correct. What you do is you simply place every value where there's an x in the original equation by the solution which you found. In this case, it will be 5.5. So let's just try that. To check now, it will be 5.5 plus 7, 5.5 plus 5 over 7. The answer should lead us to 3 over 2 or 1.5 or 1.5. 5.5 equals to 5.5 plus 5 equals to 10.5 divided by 7. 7 into 10, 1 remainder 3. 1 remainder 3. Then 7 into 35 is 5. So answer is correct, or 3 over 2 expressed as an improper fraction. So answer is correct. Our solution is very, very correct. So checking like this helps you, just in case you're not sure and you are doing paper 1 where there's no calculator. You can just check if you have time, but probably after you are done writing the paper. Press 200 kilometers as a speed in kilometers per minute. This one is a simple problem because you're just converting hours to minutes. What we do, we express the speed in kilometers per hour, 200 kilometers over 1 hour. And 1 hour, we know that it is equal to 60 minutes. So it will be the same as 200 kilometers divided by 60 minutes, which is equals to, we divide by 10, 20 over 6. We can further reduce it to its lowest term with 10 over 3. So this will give us 3 and 2 over 6, which can be reduced to its lowest terms, which is 3 and a third. So 3 and 2 over 6 kilometers per minute, or 3 and 1 over 3 kilometers per minute if we reduce that 2 over 6 to its lowest terms. You should always remember to leave numbers in their lowest terms because it makes it easier to express, and it is usually the most correct answer. Whenever there are common factors between the numerator and the denominator, it is always easier to leave in the lowest terms. Again, you can see here that we have fractions. So this question tested your knowledge of fractions to a great extent. Next question, find the time taken for a racing driver to cover a 120 kilometer race if it travels at a speed of 200 kilometers per hour, giving you answer in minutes. So if the answer is supposed to be in minutes, it means that our speed must also be in minutes. We've already calculated the speed in kilometers per minute. We can use our triangle. Speed equals to distance over time. So we can express our timetable, our triangle like this. And what we do next is very important. Since we're looking for the time, so it means that time is equals to distance over speed. Okay, it's very easy to use this triangle. Distance equals speed times time, speed distance over time, time distance over speed. So the distance covered is 120 kilometers. So we're now just going to substitute into our equation 120 kilometers, and our speed is 3 and a third kilometers per minute, or 3 and 2 over 6 kilometers per minute. If we leave our answer in terms which are not in the lowest terms, it means that we have to do an extra step in finally getting to the correct answer. So, and we will still have to reduce to its lowest terms. So here we have 3 and 2 over 6 per minute. So again, we are using fractions, 120 kilometers being divided by 3 and 2 over 6 kilometers per minute. So again, we're going to convert this mixed number to an improper fraction so that we may be able to divide properly and with ease. 120 divided by 3 times 6, 18 plus 2, 20 over 6. You see where alright, so we divide by 20 over 6 kilometers per minute. So dividing by a fraction is easy. We multiply by the reciprocal or the inverse. We just invert the numbers. 20 over 6 to become 6 over 20. And then it will be minutes over kilometers. Because since the kilometer was on top and the minute was below, so we also invert those ones. Then the kilometers will cross out each other. Then 120 divided by 20 into 20. 120 divided by 20 is equals to 6. Then multiply 6 times 6, which we get 36 minutes. So we will need 36 minutes to travel 120 kilometers. 36 minutes. Since the answer is required in minutes, we'll for the number of minutes and we are good to go. So like I was saying, you could have written 3 1/3, you still have gotten the answer correctly. Remember to write the correct answer in the space given. In this case, we should always try to write the answer in the lowest possible, in the lowest terms. So in this case, it will be 3 1/3. It is better to write 3 1/3, and then our minutes is just 36 minutes. Factorize completely, another algebraic expression kind of question. We're now on factorization of algebraic expressions. To factorize, you must look for common factors between or amongst the terms. So you can group the terms. If there's no need of grouping, then no problem. So first, you find the common factors, and then you group them, then you solve, you factorize. So first find the common factors, then you factor them out. Next, you add the remaining factors, and then you're done. So that will be very easy. Find common factors, add remainders. Let's see if that works for the first one. The first one, the common term is 4, or common factor is 4. Then we remain with y and minus 1. So if we add y plus minus 1, it gives you y minus 1. So it's 4 bracket y minus 1. The second one, xy squared minus 4x plus 2y squared minus 8. You can just work with it like it is because I can see some common factors there. First common factor would be x, and the second one will be 2. So let's get it. X is a common factor here, so we factor it out. We remain with y squared minus 4. And then we maintain the sign there. 2 is the common factor, and we remain with y squared again minus 4. Next, we have y squared minus 4 plus, or bracket x, or x plus 2. Now you can notice here that this is not the final answer. Why? Because y squared minus 4 is a product of 2 squares. Okay? So it is a product of the sum of squares. So what we will do here is we will need to express y squared minus 4 as a factorized problem. So remember, the sum of 2 squares exists when we have like x squared minus a squared. So the expression of x squared, x plus a bracket x minus a. So y squared minus 4 is the same as y plus 2 and y minus 2. So y plus 2 bracket y minus 2 bracket x plus 2. This will be the final form of the factorized problem. Okay, so this one is showing a difference of 2 squares. The difference of 2 squares. Difference of 2 squares. So y plus 2 bracket y minus 2 bracket x plus 2. That will be our final answer. Solve the simultaneous equation. Again, this is algebra, but an extension now. We have a simultaneous equation in which you're supposed to solve 2 unknowns using a system of equations. In this problem, it will be easier to use an expression which is going to give you the simplest or the quickest answer. And there are many methods we can use to solve simultaneous equations. We can solve using a method of substitution, where we substitute one of the values with another. We can use elimination. We can use graphing method as well. So there are about 4 methods which we can use to solve this. So let's start by substituting. In substitution method, what we will do is we are going to make one of the problems or one of the expressions a subject of the formula, then use it, substitute it into the other equations. In elimination, we are going to eliminate one unknown. When we solve for the first unknown, then we use that solution to find the second unknown. So let's see if we're going to get the same answer. 5d minus 3e is equals to minus 1. Let's make d the subject of the formula. 5d minus 3e plus 3e is equals to minus 1 plus 3e. I skipped a step there. So 5d equals to 1 minus 1 plus 3e. We're going to divide both sides by 5. We're going to divide both sides by 5 so that we only remain with d. Then we have d is equals to minus 1 plus 3e over 5. Now this is our intermediate value of d. We're going to use this intermediate value of d to find e first. When we find the true solution of e, or the numerical solution of e, then we're going to use it to find the numerical solution of d. So we're going to substitute this into the second equation. Why, if we substitute it into the first equation, we're going to get 0 is equals to 0. Doesn't make sense. So we substitute it to the second equation. 2 bracket minus 1 plus 3e over 5 is equals to, or plus 3e is equals to 8. Then we're going to multiply everything by 5 so that we remove the fraction part. Always whenever we encounter fractions, we should remove them as quickly as possible. Then we remain with 2 bracket minus 1 plus 3e plus 15e is equals to 40. Then we expand the brackets. 2 times minus 1 is equals to minus 2 plus 2 times 3e is equals to 6e plus 15e is equals to 40. Then next, what we do here, we bring the like terms together, add them if possible. Minus 2 plus 21e, 15 plus 6 is 21, equals to 40. Then what we'll do next is we're going to bring terms together, move the 2 from the left to right. So minus 2 plus 21e is equals to 40 plus 2. Then we get 21e is equals to 42. Divide both by 21, since it's want to remain with e only, and we get the final value of e as 2. So now we have the numerical value of e, which is equals to 2. We're going to use that one to find the value of d. Take note here, you can substitute it in any of the equations. You will still get a correct answer. You can substitute it into the second or into the first, no problem. Let's substitute the value of e into the first equation. 5d minus 3e is equals to minus 1. Wherever there is an e, we're going to put that value of 2. So we can express this as 5d minus 3 bracket 2 equals to minus 1. It will become 5d minus 6 equals to minus 1. Then we are going to bring like terms together. 5d minus 6 plus 6 equals to minus 1 plus 6. Then 5d is equals to 5. Then we are going to divide both sides by 5 so that we only remain with the value of d, and our final value of d is equals to 1. So that means our value for d is 1 and our value for e is 2. You can of course check by substituting both values into any of the to see if it satisfies the given terms. Next, we want to use the method of L to check whether our substitution is correct, and to also determine which method is easier or quicker, since you do not have a calculator and you have a lot of questions. 5d minus 3e is equals to minus 1. Then 2d plus 3e is equals to 8. What we can do is eliminate e there, because there's 3e on top, minus 3e on top, and 3e. So to eliminate the second one, or to eliminate e, we can simply add the two equations. If we add the two equations, minus 3 is going to cancel out positive 3. And then we'll only remain with terms in d, and then we can solve them. That's the method of elimination. Method of elimination just needs us to find one term which we can eliminate. In other cases, you may need to do some multiplications, but the answer will still be correct. So eliminate e first to find d. We just simply add equation 1 to equation 2. 5d plus 2d equals to 7d, minus 3e plus 3e equals to 0, minus 1 plus 8 equals to 7. 7d is equals to 7. We divide both sides by 7. 7 into 7, 1. And 7 into 7, 1. So d is equals to 1. Automatically, there's no need to continue because since the value of d is the same, it also implies that the value of e is the same. But to me, the method of elimination in this problem appears to be faster. 5d minus 3e, we're just going to do it so that it is easier to follow through. 5d minus 3e is equals to minus 1. 5 bracket 1 minus 3e is equals to minus 1. Then we subtract 5 from both sides. Then we have minus 3e is equals to minus 6. Then we divide by minus 3 both sides. And our value for e is equals to 2. Still the same. It will still be the same. So it seems like we used fewer methods in the method of elimination for this problem. I'm not saying this is the ideal problem, but for this kind of problem, it is the same. It is the same. For this kind of problem, the method of elimination does the answer in fewer steps. So when you practice a lot, you by nature see which method is the one which is going to get you to the answer the quickest. Okay? So in this one, elimination would be the best method. You can of course use a graph, but it will take too much time. I think these methods are fine like this. Solve the equation x plus 3 squared equals 49. Again, you can use any of 4 methods. You can use any method. You can use the expansion method. You can use the graph method. You can use any method which you want, which will get you the answer. We're going to first expand. You can also use eliminating the square. It depends on you. X plus 3 squared can be expressed as x plus 3 multiplied by x plus 3. Gives us 49. Okay. Then we can expand this where we're going to just maybe 1 or 2 methods. But the simplest one here would be using completing the square. But let's start with this one. Here we're going to have x multiplying all the terms in the next bracket and 3 also multiplying all the terms in the next bracket. So we're going to have x squared plus 3x plus 3x plus 9 is equals to 49. Plus 9 equals to 49. Right? Then we're going to bring like terms together. X squared plus 6x plus 9 to 49. Again, we still have like terms which we need to bring together. So this is called grouping and factoring. Alright? So we need to bring 49 to this other side. So it will be x squared plus 6x plus 9 minus 49 equals to 0 now. Again, we still need to operate that 9 minus 49. So it will be x squared plus 6x plus 9 minus 49 equals to 49 minus 9. Then x squared plus 6x minus 40. Remember, when you're subtracting, we go to the left side of the line of a horizontal number line. So x squared plus 6x minus 40 equals to 0. We now have a different quadratic equation. Quadratic equations can be solved using many methods. We can solve them using the quadratic equation, difference, splitting the square, using a graph. Depends with you. Using the grouping and factoring method, which we are going to use now. In the grouping and factoring method, we first find the factors of the values or of the coefficients of A and C, which are 1 and minus 40. And then if the sum of these factors individually can add up to the coefficient of the term in X, or the one in the middle, then we're good to go. So we're going to look at factors of minus 1 times minus 40, which is equals to minus 40. So minus 1 times minus 40, minus 2 times minus 40, minus 2 times minus 20, 20 times minus 2, 8 times minus 5, minus 8 times 5, 10 times minus 4, minus 10 times 4. So you can see that for us to be able to get 6, positive 6, we need to use 10 and minus 4. Okay, so if we add minus 1 plus 40 with 39, minus 2 plus 20 we get 18, minus 20 plus 2 minus 18, 8 minus 5, 3, minus 8 plus 5 minus 3, 10 minus 4, 6. This is the one that we want now. This is the one we want. And minus 10 plus 4 gives us minus 6. So the one which we want is 10 and minus 4. So we're going to express 6x as a sum of 10x plus minus 4x. Okay, so that will be x squared plus 10x minus 4x minus 40 equals to 0. Then we are going to factorize now this one, because it's now easier to factorize. So it will be the common, we can rearrange here. Since the common factor here, the first one is x. Since the common factor is x, we can factor out x plus 10. Then we can factor out minus 4 bracket again x plus 10. Remember we said that if we are solving quadratic equations, we find the common factor, which is x plus 10, then we add the differences, we add the remainders. So the remainders are x and minus 4. X plus minus 4 is equal to x minus 4, and then the other bracket is x plus 10, giving us 0. So in this problem now, you can see that if the product of two numbers is equal to 0, then it must imply that one of those numbers is 0. Like for example, with two brackets, x minus 4 and x plus 10. What this is implying is either x minus 4 is equal to 0 or x plus 10 is equal to 0. So we're going to solve based on those assumptions or those premises. All right. So in this case, we're going to use either x is equals to x minus 4 equals to 0, or x plus 10 equals to 0. In which case, x minus 4 equals to 0 means that the value of x is equals to 4, or x plus 10 equals to 0. It means that the value of x is equals to minus 10. So you can choose which of the methods you want. You can use completing the square. It's very direct and straight to the point. The quadratic equation is a bit longer and requires a few extra steps. You can use a graph and find the points of intersection. That's one way of doing it, but you do not have as much time as you would like to explore all these 4 methods to solve quadratic equations. So if you cannot use completing the square, use the grouping and factoring method. If you cannot use both of them, then use the quadratic equation. Only when you cannot use it directly, like let's say the graph or the quadratic equation seems to be a graph of a parabola, and then if the equation gives a parabolic graph, then obviously we have to use a graph. So this factoring and grouping method is the one which I used here. It was the one which is, you can use completing the square. In this case, it would be easier to use completing the square, since you can just find the square root of the left hand side and then find the square root of the right hand side, and then equate the roots of the left to the roots of the right. All right, that will be easier. For the second part, it says find the prime numbers between 20 and 30. So we just list out the prime, all the numbers from 21 up to 29. From 21 up to 29, it's very simple. See if it has got factors. So 21 is equal to 3 times 7, which means it will not work. 22, 11 times 2, it won't work. 23 equals to 1 times 23. This is a prime number because it only has 1 and itself as the only factors. So 23 is a prime number. 24, 8 times 3, 12 times 2, it won't work. 25, 5 times 5, it will not work. 26, 2 times 13, which will not work as well. 27, 9 times 3, it won't work. 28, 7 times 4, 14 times 2, it's not a prime number. And then 29 is equals to 1 times 29, and it is a prime number because it only has 1 and itself as the only factors. So take note, when you're working with prime numbers, remember a prime number is a number that it only has 1 and itself as the only factors of that number. So 23 and 29 are the only prime numbers between 20 and 30. Simplify x squared plus 3x plus 2 divided by x plus 2 as our first part. In this one, we will need to factorize the first expression, x squared plus 3x plus 2, so that we can see if one of the factors of this number is a factor of, is also can be crossed out with x plus 2. Right. So what we do is we're going to use the grouping and factoring method to factorize this quadratic expression. X squared plus 3x plus 2x plus 2 can be expressed as x squared plus 1x plus 2x plus 2. How do we do this? We're going to work it out to group it on the side. So we're going to find the of AC, with the coefficients of the term in x squared and the coefficient of the term in x to the power 0, which is just the term without the x value there in the quadratic expression. So we need to find factors of coefficient of x squared is 1, coefficient of x to the power 0 is 2. So 1 times 2 is 2. So we need to find factors of 2, which we add them singly or separately gives us 3. So we have 2 times 1 and 1 times 2, and minus 1 times minus 2 and minus 2 times minus 1, which is just the same thing. So if we add 2 plus 1, we are going to get 3. If we add minus 2 plus minus 1, we're going to get minus 3. So the factors that we want are 2x plus x. 1x can be written as x, then plus 2. X squared plus 2x can be factorized. X is a common factor, bracket x plus 2, plus 1 is a common factor there, bracket x plus 2. Then the common factor in both of these expressions is x plus 2. So what we do is we factor out or write out the common factor first, then we add the remainders, which are x plus 1. So x squared plus 3x plus 2 can be expressed as x plus 2, bracket x plus 1, divided by x plus 2, which will give us, we can just divide the denominator and the numerator, since they have common factor x plus 2, x plus 2, and we are going to remain with x plus 1. That is our final answer there, x plus 1. So there's our 3 marks. We took the straightest and most forward path, and we did not skip any steps. Second one, find the order of rotational symmetry of a right-angled isosceles triangle. Again, in this problem, it's quite simple. What you simply do here is you need to check your triangle. I have a triangle here, so you can see that the only way in which we're going to rotate this triangle and bring it back to its original shape, or to superimpose on its original shape through a 360-degree turn, is once. All right, so this is a right-angled triangle. So if it's isosceles, it means that the two sides stemming from the right angle are equal. The two sides do not have to be the hypotenuse. The hypotenuse is different. So the order of rotational symmetry of a shape refers to the number of times that a shape can be superimposed on itself or can maintain its original configuration through a 360-degree turn. You should remember by now, or at least you should know, that all regular shapes, which means that all shapes with an equal number of sides, or with the sides which are equal in length, have got an order of rotational symmetry which is equal to the number of sides. For example, a square. A square has order of rotational symmetry 4. An isosceles triangle which has got all sides equal is order of rotational symmetry 3. So in my diagram here, I'm going to make this the center and then rotate my shape through 360-degree turn. So we want to see how many times it can maintain this configuration. Here it is like a reflection, it is not in the configuration. There again it is not. If we do it like that again it is not. And it only returns after one complete rotation, which means that the order of rotational symmetry here is 1. So this shape, the isosceles triangle, isosceles right angle triangle, only turns once. For another video on triangle geometry, you can check out this video so that you can understand more about triangles. So we can also say that this only fits once onto itself through a 360-degree turn or through one revolution. You can also check out our other geometry questions on. Meet you in the second part, which concludes the paper.